everyone! Today we are tackling a big one, statistics. Now, I know what you might be thinking. Math, boring charts, just a whole lot of complexity. But I want you to try and think about it in a totally different way. Think of it as a superpower for turning all that noise out there into actual meaning and for understanding the world with a bit more clarity. All right, let's jump right in.
I mean, seriously, every single day we're just hit with this fire hose of information, right? Numbers, data points, headlines, it's coming from everywhere. It can feel completely overwhelming. So the big question is, how do we cut through all that clutter? How do we find the signal in all that noise? Well, that is the exact problem that statistics was invented to solve.
And at its heart, that's really all statistics is. It's a method to the madness. It's a way to take all that raw, messy data and transform it into a picture that we can actually understand. It's the science of making sense of things, from figuring out if new medicine works to understanding why a product is selling. It's all about finding clarity in a really complex world. So, to get a handle on all of this, we're going to break it down into 4 simple ideas. First, the basics of making sense of data. Then, we'll talk about how to describe what you see. After that, we'll get into how to make an educated guess. And finally, we'll look at how to find those hidden relationships in the numbers. All right, first step, making sense of data. It might seem like a huge field, but honestly, pretty much everything in statistics comes down to answering 2 and only 2 big questions. And once you get these, everything else starts to click into place. And here they are. These are the 2 main jobs that statistics does. On one side, you've got descriptive statistics. This is all about summarizing the information you actually have in your hands. It's asking, what does this specific group I studied look like? But then on the other side, you've got inferential statistics. And this is where we take a leap. It's about using that small group to make an educated guess about a much, much bigger group. So let's really dig into that first one, descriptive statistics. This is the foundation. It's all about telling the story of the data that you have right in front of you, nice and clear. So imagine you're just looking at a big pile of numbers. What's the very first thing you'd probably want to know? Well, you'd want to know what a typical value is, right? What's the middle ground? In the stats world, this is called finding the central tendency, and it's always the first step to painting a clear picture. Now, here's the thing. There isn't just one way to define the center. There are 3 main tools for the job. You've got the mean, which is just the good old average we all learned in school. Then there's the median, which is the person or number smack dab in the middle if you line everyone up. And finally, you have the mode, which is just the most popular choice, the one that shows up more than any other. Okay, let's make this real with a super simple example. Let's say a company asks 30 employees how they get to work. The very first step is just to get organized. You'd make a simple frequency table like this. It's just a clean summary that shows us, 14 people drive, 6 ride a bike, and so on. But you know what they say, right? A picture can tell you so much more. The second we turn that table into a simple bar chart, the story just pops right out at you. You can't miss it. That huge bar for car tells you everything instantly. And just like that, you understand the mode. Car is the mode of transport here, simply because it's the most common answer. See, that's descriptive statistics in a nutshell. Okay, so that's all about describing the data we actually have. But what about all the people we didn't survey? This is where we make that big leap into inferential statistics, using a small group to understand a massive one. And this is where statistics gets really, really powerful. Now, to make that leap, you have to get your head around 2 key ideas, the population and the sample. The population is the whole enchilada, the entire group are curious about, like every single adult in the United States. Obviously, that's impossible to study. So what do? We take a sample, just a smaller, manageable slice of that population that we actually can study. The whole game is about using that little sample to say something smart about the entire population. So how do we actually do that in a way that isn't just wild guessing? The main tool for the job is something called hypothesis testing. Don't let the name scare you. Think of it like a court case for your data. It's a formal, structured process for putting a claim or a theory on trial to see if your sample has enough evidence to back it up. And it really just boils down to 3 core steps. First, you start by playing devil's advocate. You state what's called the null hypothesis, which is basically assuming your idea is wrong, that there's no effect or no difference. Second, you look at your sample data and see how much it disagrees with that no effect world. And third, you calculate something called the p-value. The p-value. It sounds super intimidating, but the idea behind it is actually pretty simple. I want you to think of it as a fluke meter. That's all it is. The p-value tells you the probability that you would see results like yours just by pure random chance, if that no-effect idea was actually true. So a really low p-value means your result is probably not a fluke. So what counts as low? Well, in most scientific fields, the magic number is 0.05. That's a 5% chance. If the probability of your result being just a fluke is less than 5%, scientists will usually reject that no-effect idea and conclude they've found something real. It's kind of the unofficial line in the sand between a random coincidence and a finding that's statistically significant. Okay, so we can describe groups and we can make educated guesses about them. The final piece of the puzzle is all about finding connections. How does one thing relate to another? This is where we look for those hidden relationships in the data, using cool tools like correlation and regression. Now, these two ideas are cousins, but they do different jobs. Correlation just asks the simple question, is there a link here? As one thing goes up, does the other thing tend to go up or down? Regression, on the other hand, takes it one step further. It asks, okay, there's a link. Can we actually use it to build a model and predict one thing from another? But this brings us to what might be the single most important rule in all of statistics. If you remember one thing, make it this. For any data detective out there, just because two things are correlated does not mean one causes the other. The classic example is that ice cream sales and sunburns are highly correlated, but eating ice cream doesn't cause a sunburn. There's a third factor, hot, sunny weather, that's causing both. You've got to always remember that. So, there you have it. We've covered the basics, describing what you see, making educated guesses, and finding relationships. We've seen that statistics isn't really just about math. It's a way of thinking, a way of being critical about the information you see. So the real question now is, with these tools in your pocket, what patterns are hiding in the data all around you?